In this worksheet, we have listed all the equations that you will need to solve these problems. The first problem is, if a car is moving from rest with an acceleration of 15 meters per second, how fast will the car be going in 60 seconds? And to figure this out, you would list all your given variables, including the one that you don't have. And then you would choose which equation you would want to use. In this case, the most easy equation to use is V equals V initial plus AT. You would then plug in all your known variables and then use basic algebra to discover what V is. In this case, you would multiply 15 times 60 to get 900, which becomes meters per second, which is how fast the object is going after the time given. In question number 2, it asks if a car is moving 12 meters per second and comes to rest after 50 meters, what is its acceleration? In this case, you list out that you have V initial equals 12, V equals 0, and X equals 50. And you're looking for A. So A, question mark. In this equation, if we look at all our variables, we discover that the V squared equals V initial squared plus 2A delta X equation is the best one to use. So now you fill in V equals 0, V initial equals 12, 2A, what we're looking for, and 50, the distance. You would then take the square root of 12, which is 144, and then 2 times 50, which is 100. Subtract 144 from both sides, and then divide 100 by both sides, giving you negative 1.44 equals A. For question number 3, what is the average velocity of an object that has moved 20 meters over 60 seconds? This is a much easier problem because you only have two variables, delta x, the displacement, and t, the change in time. To find average velocity, you would just do delta x divided by delta t. 20 divided by 20 gives you 1. What is the average acceleration of an object that has moved 35 meters over 70 seconds? This is basically the same problem, you're just looking for the average acceleration instead of average velocity. You're doing the distance divided by the time, which is 35 divided by 70, which gives you 0.5. Question 5, it asks, an object that has moved 30 meters starting from rest in 70 seconds has an acceleration of what? This equation you list out, you have delta x, which is 30, v initial, which is 0, and t equals 70. In this equation, for this problem, you can use the equation x equals x initial plus v initial t plus 1/2 at squared, because v initial in this case is 0, making so that you can get rid of the middle portion of the problem and just end up using the 1/2 at squared part. So x equals 1/2 at squared, so you plug in 30 equals 1/2 a 70 squared. Now you have to rearrange the equation using algebra to figure out what a is. So you do 70 squared times 1/2, which gives you 2,450. You would then divide 2,450 by 30, giving you an acceleration of 0.012 meters per second squared. In the last question, a person is running from rest with an acceleration of 20 meters per second squared for 30 seconds. How fast is he moving? For this, you list out that you have the person starting from rest, making the initial velocity 0, acceleration 20, and the time is 30 seconds. You then plug that into the v equals v initial plus at equation, giving you v equals 0 plus 20 times 30. In this equation, you would simply multiply 20 and 30 to give you 600, and that would give you the final velocity.